Hi guys, in this video I'll be talking about how alternative splicing took place, and I'll give you some example. One most important example of the alternative splicing is basically the production of, I'm just giving in a short, production of T antigen. Okay, whenever SV40 infects the mammalian cell, T antigen produced. But this T antigen from one gene, okay, this T antigen that is produced from one specific gene, but it has two forms. One is large T antigen and one is small T antigen. One is large, one is small. Two different types of antigens means two different types of proteins are producing from a same or identical gene, that is T antigen gene. Okay, now what happens, I'll show you. Suppose the T antigen that has two introns, intron 1, intron 2. Okay, this is a conventional T antigen genome. Now after their transcription, this is the premature mRNA and this is intron. Okay, now this intron has a stop codon. Okay, this intron has a stop codon, this one. Now what happens? Due to splicing from this premature mRNA, what happens? E1 and E2 will be spliced together, means the exon 1 and exon 2 will be spliced together, and that will form T antigen mRNA, and that is mature mRNA. Now from this mature mRNA, obviously T antigen protein will be produced. Okay, this is the basics, or this is the concept of the splicing, whether alternative or conventional. So during alternative splicing, what happens? From T antigen premature mRNA, okay, first one is large T antigen will be produced. It means only E1 and E2, the exon 1 and exon 2 are present and spliced together. Now what happens in their second type of splicing product? Okay, what happens? Intron 1 and intron 2, they are spliced, but they contain exon 1, exon 2, they will be spliced, but sorry, I've mentioned it as a intron, it's a mistake, very sorry. The intron is present in between exon 1 and exon 2 along with the stop codon of the intron. The stop codon, remember, that is present in their premature mRNA, and after the alternative splicing, what happens? E1, E2 and the whole intron, they all are spliced together along with the stop codon of it. So due to this, what happens? Due to the presence of the stop codon region, protein synthesis will be stopped at this point. Okay, so that is why they produce small T antigen. Here the small and capital letter means it's not like I just only denoted them on my own like a T, capital T or small t. No, it's not like that. Capital T means the full large shaped protein, though it looks like that these T antigen mature mRNA, that is, if you just compare these two structures, it seems like they are smaller than this one. Then why they don't produce the large T antigen? Why this is small T antigen? Why it is not large T antigen? Why? Because of the presence of this stop codon within the intron. Obviously the protein translation that will be stopped there, and the small sized protein will be produced from this alternative spliced mature mRNA. That is why even after this mature mRNA looks smaller in size in that mRNA, that will give rise a large sized protein, because they don't have this intron portion with the stop codon. Okay, maybe there is a presence of stop codon and it looks like it's, oh okay, it's a very large sized mRNA. No, it is a large sized mRNA, but from protein synthesis point of view, as it has a stop codon within it, so obviously the protein synthesis will be seized here and it will produce a very small shaped protein. That is the small T antigen. Okay, clear? So in this way, alternative splicing takes place in the mammals whenever the SB40 infection arises, and this is a perfect example of the alternative splicing. Hope I can make you guys understand, and if you like this video, please subscribe my channel and share with your friends. Have a good day.